Alright, so let's look at probably the most popular quadrilateral that is on the ACT, the trapezoid. The trapezoid comes in two different forms. As you see here, isosceles trapezoid and the non-isosceles trapezoid. Alright, so let's start with, before I get to this point, I just want to make out and show you that the trapezoid has one set of parallel lines. Alright, so base angles are congruent. This is just like a isosceles triangle, as if the top of the isosceles triangle got cut off. So in an isosceles triangle, it has base angles that are equal. And that's true with the isosceles trapezoid. But not only are these two congruent base angles, but these as well. And I'll just mark these differently. Okay, so it has the bottom two are equal that are across from each other, and as well as the top. So each side has supplementary angles. Alright, so this would be a side. Alright, this is called the leg, so that's called the side. And this is a leg. So on each side, these add up to 180, and then separately these add up to 180. And if you kind of see this, so that's what we're kind of seeing on each side, the co-interior angles. Alright, the diagonals are congruent, but they do not cut each other in half. Alright, so make sure you know that. Obviously, you probably can tell that this portion is not as equal to this portion on this diagonal. Alright, so let's go ahead and say, or look at our non-isosceles trapezoids. Okay, well, I need you to make sure you write this in. Base angles, this is non-isosceles. Base angles now are not congruent. Alright, meaning these two guys are not going to be equal, and either are these. So make sure you put not and whatever you want to do to help you remember. Each side does have supplementary angles. Alright, so this side does add up to 180, so that looks like our gene pockets look co-interior. And then these add up to 180 on this leg. Alright, so this works. Diagonals are congruent but not bisectors. Okay, so this is a no. This is not true. So, if I put my diagonals in here, they are not congruent. So the only thing that these two trapezoids share is gene pockets co-interior angles on each side. Otherwise, we have to pay attention to what type of trapezoid it is and make sure we know the rules for each one. Alright, so some practice problems real quick. So this is a way, you guys should be used to this. This is a way to tell us it's isosceles. If the legs are equal, they're isosceles. Now, along the legs, we have co-interior angles. So that would be 75 because they add up to 180. And the base angles here are equal. So this guy comes over here and it's also 105. And as well as up here, this base angle would be 75. Alright, another way to show isosceles, same markings again. I don't really have to do much with this. These two are equal. It's along the base, along the leg. The sides that are equal are called legs, and this is 100 because they add up to 180. Over here, there are no markings. You got to be careful. There are no markings here that say it's isosceles. I know it looks like it, but there's no markings, so you got to be careful. So we already talked about there's one thing in common. These do still add up to 180, so that would be 60 plus 120. All right, down here we have isosceles. It marks that way. The markings tell us that, and if we want to find x along the leg, along the marked side, we just add them up to 180 and create an equation and solve. Here we have diagonals in a isosceles triangle, and they are equal. So you would say G to E, which is here, and F to D is here. You set them equal to each other.